Hello everyone, how are you doing today? My name is Rex Jerry of jerry.com and beginlinux.com. The title of today's lecture is C++ Arrays.0, using C++ to create a Megamillions program. You can see this lecture in its original context at jerry.com/node/23. Okay, a quick introductory note. This lecture is not designed to promote or condone gambling. The point of the lecture is to show how real-life problems can be solved using C++. The problem you're given as a programmer is this. We need you to create a C++ program that will automatically generate Megamillions numbers for the user. Okay, the learning objectives for today's lecture. We'll explain how the Megamillions lottery works. We'll explain pseudocode. We'll explain what an array is. We'll explain the difference between a C++ array and a C++ vector. We'll explain how to create a C++ array. And then the final bonus is we'll walk through writing the Megamillions program. Okay, here's how the Megamillions works. You buy a ticket for $1 a piece. The player picks 6 numbers from 2 different pools. The first 5 numbers are 5 different numbers picked from a pool numbered 1 through 56. The last number, called the Mega Ball, which is the 6th number, is picked from a pool of numbers from 1 to 46. Pool 1 and 2 are completely independent. So the number in the 6th block in the Megamillions block could be one of the numbers that appeared in the first 5 numbers. Okay, explaining pseudocode. The very first step when I wrote this program was I wrote the pseudocode for it. Pseudocode is an informal, high-level description of the operating principle of a computer program or other algorithm. That comes straight from Wikipedia. Pseudocode is intended for human reading. Pseudocode uses structural conventions of a programming language. However, pseudocode omits details that are not essential for human understanding. For example, variable declarations, comments, etc., etc. And pseudocode has no standard syntax. Okay, pseudocode continued. The first step I did in writing the C++ Megamillions program was to write out the pseudocode. So my pseudocode had 8 steps in it. The first step was to create an array of 56 elements, then create an array of 46 elements. That first array stores numbers 1 through 5. The last array stores number 6. The next step was to shuffle the array, and then pull 5 numbers from the array 1, which was the 1 through 56 array. Then shuffle array 2 and pull 1 number from array 2. And then let's say that the user wanted to create 10 sets of Megamillions numbers. Then we would just repeat steps 1 through 6 10 times. The final step is to print the output to the screen, which is the numbers that the user wants to play. So if they wanted 10 sets of Megamillions numbers, I'll print out 10 sets of 6 numbers. Okay, explain what an array is. An array is a series of elements of the same type placed in contiguous memory locations that can be individually referenced by adding an index to a unique identifier. And this comes straight from cpp.arrays.0. So let's talk about contiguous. Contiguous memory spaces right next to each other. So memory space 0 might hold element 0 of the array. Memory space 1 might hold element 1, so on and so forth. The array size is fixed at compile time. So if I have an integer array and I say that it has 6 elements, once I compile the code, that array is a fixed size. You can't change it. Okay, explain the difference between a C++ array and a C++ vector. Vectors are part of a template class. Template class, just like the name implies, is kind of a generic form of a construct. Arrays are not part of the template class. In other words, vectors utilize generic programming, arrays do not. So what's generic programming? Generic programming is a style of computer programming in which algorithms are written in terms of to be specified later types that are then instantiated when needed for specific types provided as parameters. So in general, generic programming, instead of saying this algorithm is for integers, it would just say this algorithm is for some undefined type. We just call it like A or B or C or whatever. And then when you actually implement that algorithm, you'll say what type it is. And that definition comes from Wikipedia. Okay, the difference between a C++ array and a vector continued. An array is a fixed size. Its size must be defined in the program. Once defined, the size remains constant. A vector can be dynamically resized by adding or removing elements. Okay, explain how to create a C++ array. First, we'll do a quick review of how to create a vector. Okay, in this example here, I'll show you how to create a vector named myVector of 10 integer elements, all with the value of 5. Okay, explain how to create a C++ array continued. So the generic version of creating a C++ array is first you would say what the element type is, say int for integer. Then you'll give the array a name. Let's say my name, my array. And then in the brackets, you'll give the array size. You know, in this case, if it's an array of 10 elements, that would be 10. And then you say it equals, and then in curly brackets, you would say element 1, 2, 3, you know, however many elements they are, out to element n. For example, if I want to create an integer array with 5 elements, I would go int space my array bracket 5 close bracket equals curly brackets 5 comma 4 comma 3 comma 2 comma 1 close bracket, and then of course we ended with our semicolon. This would be a one-dimensional array. For the first dimension, the array size can be left blank, so you could just say int space my array open bracket close bracket, just leave the brackets empty, equals curly brackets 5 comma 4 comma 3 comma 2 comma 1 close bracket semicolon. So if it's just a one-dimensional array, you can actually leave the size of the array blank and just define the elements in the curly brackets. If it's a multi-dimensional array, you do have to state the size of any dimension past the first dimension. Okay, but we won't discuss multi-dimensional arrays in this lecture. That'll be for a later lecture. You can also leave the value of the element blank and define them later. So instead of me just putting in the curly brackets and saying, you know, it's equal to 5, 4, 3, 2, 1, I can just say int space my array bracket 5 close bracket semicolon, and that just creates an array with 5 elements, but the elements are undefined. Okay, so now we've got through the boring stuff. Let's go ahead and write this C++ Megamillions program. So I'll use the method that I've always used that I found to be very successful for the last few lectures. I've written the entire program, I've tested it, and now what we're going to do is we're going to write it line by line. So let me unmaximize this and pull it all so you can see the entire thing on the screen. Like that, okay? All right, so let's grab the first 3 lines. Okay, the first 3 lines are just straightforward C++ comments. The first one, I define the name of the program. The second one, the name of the file is the first line. The second one is the name of the program, using C++ to create Megamillions programs. And then the third one, I just give who wrote the program. Okay, the next several lines are just explanatory. This C++ program simulates the Megamillions lottery. It outputs as many sets of numbers as the user wants. And then it describes what the Megamillions program does. It selects 5 random white balls numbered 1 through 56. It selects 1 gold ball numbered from 1 to 46. It outputs the white balls 1 to 5 in ascending order, followed by the gold ball, which is ball number 6. Okay, the next several lines, I just say where the source code is going to be maintained, jerry.com/node/23. The next one are my included libraries, IOStream because I'm inputting and outputting from the keyboard and screen, vector for the vector functions such as .at, pushback, etc., algorithm for the srand and random shuffle functions, ctime because we need time to seed our random number generator, and IOMAN-IP because we need the setW function to set the column width of the output. Okay, next line, we're using our standard namespace. So using namespace standard, semicolon. That's for our CIN, cout, indel. And then next, we have the actual main function. So let's go ahead and do our skeleton of our main function. Int main, open parentheses, close parentheses. And then next line is our open brackets, close bracket. And remember that an integer type function always returns an integer, so we'll do return 0. Okay, now let's go ahead and write the stuff inside the main function. Okay, so the very first thing we're going to need is we're going to need to create our random numbers. So we'll use our srand function to seed our random number generator, which is the rand function. Okay, and if you watch my previous lecture, you'll remember that the srand function just takes the time from that function time, and that function time basically returns the time in seconds since January 1st, 1970. Okay, let's pull all our variables. Okay, let's look at our variables one by one. So in the Impress slideshow, we showed you how to create a an array. So we have an integer type array named balls, and the size of that array is 56. So that's going to hold our 56 white balls numbered 1 to 56. The next line, we have our integer type mega ball, and that's a size of 46. That's going to hold our 46 gold balls. Next one, we have an integer type balls out. That's going to actually hold. The way I think about it is, okay, if we look at this balls array is like a big bucket. It's a big bucket that holds 56 balls. When we pull that ball out one at a time, we got to hold it someplace. So, you know, normally you might hold the balls in. If you ever watched a lottery drawing, when the balls come out, they get stored like in a little tube or something like that, you know, and then the balls get turned around so you can actually see what the numbers are. That's what the balls out is. The balls out is like kind of the output array that holds our 5 balls that are pulled from the 56 element bucket, if you want to call it, you know, bucket, container, whatever you want to call it. All right. So now the next variable is the mega ball out. It just holds our 6 ball. When our 6 ball comes out, remember our 6 ball comes from a different pool. It comes from a pool of 46 balls instead of a pool of 56 balls. So we want to store that one separately. Okay. Then the next 3 variables, I, J, K, are all integer types. Those are just counters. They count our number of times going through loops. You'll see that a little bit later on. And then integer, int number of sets is the number of times that we're going to repeat this process for the number of sets of numbers that the user wants. So the user might only want 1 set of 6 numbers, or they might want 10 sets, or 100 sets, or 1,000 sets. However many sets they want, they get stored here in the number of sets. And that kind of directs how many times our loops are going to repeat to create new numbers. Okay, the next few lines send some messages to the user and input some data. So the next line says, cout, how many sets of Megamillions numbers would you like to generate? Okay, then the user will input how many numbers they want. So let's say 10. If they say 10, our CIN function will input 10 into the variable number of sets. And then cout inline, that's for spacing, just to make our program look pretty. Then we'll cout here are your numbers, endl, to put 2 spaces in for prettiness again. Okay, now we have a for loop. Our for loop is pretty long, so let's go ahead and generically define it. So let me go ahead and I'll just copy the whole thing, but then I'll delete the stuff inside. Control V. Alright, so let's just go ahead and delete the stuff in the for loop now so we can look at it kind of line by line. Okay, let's just go ahead and delete this, and we'll leave this first one. Okay, so the very first 2 lines of the for loop, the first 3 lines, we have a comment. The 2 lines below fill the white ball and mega ball arrays. So the first one, filling the white ball array, remember our counter that we created up here, ints I, j, and k, so we use our I for parentheses I equals 0, semicolon, I less than 56, semicolon, I plus plus. Okay, balls, bracket I, close bracket, equals I plus 1, semicolon. So what are we doing there? So our counter starts at a value of 0. 0 is less than 56, and we want to post increment I. Post increment means you can actually increment I after you do the stuff the first time. All right. So I plus plus, we're not going to increment it yet. I is still 0. So balls at the index of 0 equals I plus 1. What is I plus 1? That's 1. So we're setting balls at an index of 0 to 1. Now we post increment, so now I equals 1. We go back into the loop. So I doesn't equal 0, it equals 1 now. 1 is still less than 56. We're going to post increment I to 2. So it's still 1 right now. So balls at an index of 1 equals 1 plus 1, which is 2. All right, so on and so forth. It repeats and repeats until I equals 56. So basically all this line is going to do is it's going to fill the array balls bracket I close bracket from with the numbers 1 to 56. All right, so let's jump forward. Let's go, because this for loop will only go as long as I is less than 56. So let's jump forward to when I equals 55. So for I equals 55, 55 is less than 56. We're going to post increment I after we do the stuff to 56. So balls at an index of 55 equals 56. All right, and then we go to the loop next time. I equals 56. 56 is not less than 56, so now we break out of the loop. So it's just fill the array from 1 to 56. The next line is the exact same thing. We use a different counter. We use j, but it's an integer type again. J equals 0. 0 is less than 46. We're going to post increment j to 1. So right now it's still 0. Mega ball 0 equals 1. Okay, so on and so forth. So just repeat the same way we repeated the previous counter, and it'll fill the mega balls array, the mega ball array with numbers 1 to 46. Okay, pretty straightforward, right? Easy stuff. Okay, the next couple of lines, we're going to actually shuffle those arrays that we've just filled. So let's copy that. And you remember in the last tutorial we did, or one of the recent tutorials we did, we showed how to shuffle a vector. Shuffling an array and shuffling a vector are very similar. So let's... Okay, so the first one we're doing is we're shuffling the white ball. So we use the random shuffle function that we were familiar with from our vectors lecture a couple of weeks ago. And you give it the address of the array elements that you want to shuffle. So that and symbol is a by reference. By reference references the memory address of the element, vice the element itself. So we want to randomly shuffle whatever's at the address of index 0 of the balls array to index 56 of the balls array. So basically from number 1 through 56 of the balls array, we're going to randomly shuffle those numbers. So remember when we created that array, when we filled that array, we filled it from 1 to 56. Now we're going to randomly shuffle it. So the first one might be, 53, the second number might be 13, so on and so forth. We're going to do the same thing with the mega ball array. We'll shuffle those 46 numbers randomly. Okay, so the next thing we're going to do is we want to pull our 5 numbers from the balls array, and we want to pull our 1 number from the mega ball array. So remember that when we pull our 5 numbers from the balls array, we're going to store that in balls out. So that should make sense. So we're using our I counter again, starting at a value of 0. For I equals 0, I less than 5, which is the size of our balls out array, I plus plus. So right now we're going to post increment I to 1. So right now it's still 0. So the 0th element of balls out equals the 0th element of balls. So all we're doing is we're basically pulling our 5 numbers starting at the very beginning of the balls array after it's been shuffled. That's very important. So the values in the very beginning of the balls array are now random. So we post increment it to 1. So now I equals 1, I less than 5, I plus plus. We're going to post increment, so I is still 1. So balls out 1 equals balls 1. So all we're doing is we're setting the 5 elements of balls out equal to the first 5 elements of balls. Remember, balls is a 56 element. We're just taking those first 5 elements. Okay. Then we're doing the exact same thing with the balls out variable. The balls out, I'm sorry, mega ball out. We're doing the exact same thing with the mega ball out variable. So mega ball out equals the value stored in mega ball index 1. So remember, we randomly sorted mega ball 1 through 46. So that first element could be anything. It could be, 10, 9, and I could have said mega ball 0. It really doesn't matter. It's randomly sorted, so I could say any one element of mega ball is what we're going to pull. I just decided to do 1, and I think that was kind of a mistake on my part. I typically would have done 0, but that's fine. 1 is going to be randomly. It's going to be a random number, so between 1 and 46, so that's fine. Okay, the next thing we're going to do is we're going to want to sort the balls out from lowest to highest, because right now, balls out is just 5 numbers randomly from 1 to 56, but they're not in any specific order. So what we're going to do is we're going to use our sort function. What we're sorting is we're sorting the balls out array, and we want to start, we basically want to sort it from balls out, the beginning of balls out, to the end of balls out. The way you do the end of balls out is you do the size of function. So the size of balls out is going to be 6 divided by the size of the first element of balls out, which is 1. So basically, you're telling it what the size of balls out is. 6 elements. You're going to sort it from the beginning of balls out to the end of balls out. So if balls out is, say 39, 53, 21, 47, and 11, it's going to sort that out. So whatever the lowest number is will be at the beginning, let's say 11, and then it'll incrementally increase them. It'll put them out in rising value, basically. Sort them in a rising manner. Okay, so the very last thing we're going to do is we want to print this output to the user. So we're going to use a print function. Now you remember that the last time I used an external print function. I defined my print function at the bottom, but you can also do it inline. You can put your print function right in your main function if you want. And depending on the length of your program, one might be appropriate, another one might be appropriate. I could have done an external print function, but I said this is pretty short, pretty quick. Let me just write it and put it in the main function. So the print function, we have a for loop again, and we have our I counter again for I equals 0, I less than 5, I plus plus. We're going to see out. Now this set width function, we've seen that before. The set width sets the column width of our output. So basically 5 column output, and then we're going to print the balls out at a given index. So I equals 0, so we're printing out the value at balls out 0 index. And then I equals 1, so on and so forth, until we print all 5 elements out. And then we have this space here just for spacing to put some nice, space in between the numbers. Our set width also kind of does that, but I put this in here to make it a little bit prettier, after playing with the output. And then the next line, we're going to see out, set the width to 6 columns, the mega ball out, which is just 1. I put 6 instead of 5 here to put a little bit of extra space, so you can definitely tell that the mega ball out is kind of its own number. It kind of stands alone. Okay, and I think we are done. We've closed out our for loop. We have our return 0. So this should be ready to run. So let's go ahead and save it. And then we're going to open up code blocks. And in code blocks, I'll go to the directory where this is stored, which is node 23, C++ files, C++ arrays0.cpp. Okay, there's our program. Okay, so far everything looks good. Let's go ahead and build and run it. And there we go. Let's make this a little bit bigger. Okay, so how many sets of Mega Millions numbers would you like to generate? Let's say 10. Okay, and here are my numbers. Now let's do a quick test on it, make sure that it meets all the criteria. So remember that these first 5 columns are balls 1 through 5. Number 1, none of the numbers should repeat because each time we generate a number, we're pulling that number out of the pool. So 6, 20, 31, 53, 56, that passes that test. The second test is every number should be between 1 and 56. 6, 20, 31, 53, 56, everything's between 1 and 56. And then remember that the 6th column got pulled from a different pool. And that pool was 1 to 46. So doing a quick dummy check all the way down, everything here is between 1 and 46. So it looks good. Now the third test is no number in the 6th column should be a repeat of any number in the first 5 columns because the 2 pools are completely independent of each other. All right, so 23 doesn't exist here, 8 doesn't exist here. Oh, I'm sorry, that's backwards. Since the 6th column is an independent pool, a number could be repeated. So, you know, I'd have to run it enough times to see that something is repeated, but in theory, a number that appears here could appear here. I don't see an example where it does, but I'm pretty sure that it works fine because I did create 2 separate pools for it. So I would have to repeat this several times though. Oh no, there we go. There we go. Okay. So if you look at the last one, 21 appeared in the first 5 numbers, and it also appeared in the 6 numbers. So that passes that test. So it looks like our code is good, and we successfully created a program that simulates the Mega Millions. Okay, so like going back to our lecture, let's see where we are. Okay, so we did write a C++ Mega Millions program. So a quick review of our learning objectives. We explained how Mega Millions works. We explained pseudocode. We explained what an array is. We explained the difference between a C++ array and a C++ vector. We explained how to create a C++ array. And the final fun bonus is we walked through writing a Mega Millions program. Thank you for watching. I recorded this on a beautiful Saturday afternoon. Probably should have been outside instead of inside writing this, but I enjoyed it. If you want to review this lecture, if you want to get more information, the write-up for the lecture is at jerry.com/node/23. Have a great day, week, and year. Bye-bye.